Hey everyone, Troy Richardson here. In this presentation, we're diving into a crucial aspect of ziplining that often gets overlooked: how to determine zipline arrival speeds. Because ziplining is not just about the thrills, it's about safely stopping zipliners so everyone can enjoy the experience. Let's zip right into the training. Where this video fits in emergency brake training is under zipliner arrival speed, how to determine arrival speeds. We will also look in other presentations on how the standards apply, the mathematics involved in ziplining, and injury prevention. We'll also look at different types of emergency brakes or EADs and inspections. But for now, let's just stick with determining arrival speeds. The 5 quiz questions that you received in the pre-test will be answered in this presentation, so take notes. Why do we need to know a zipliner's arrival speed? The answers include: because knowing the arrival speed reduces risks. Knowing the arrival speed aids for the proper braking system design. It also helps you meet the requirements and standards in your area. Arrival speed data can help you determine what braking needs you have. And speed data can help you so you can design the proper braking system. Let's look at this video. This video has some accidents that I've investigated. Please note the graphic nature of some of these incidents may be disturbing. As I show you some of the reasons why we determine arrival speeds, you'll notice that none of these ziplines have emergency brakes, and all 3 participants are injured. Let's watch the video.
I'm not trying to do a backflip off it.
Notice how the guide is not even listening to the zipliner coming down.
It's not gonna feel good if I miss that.
Not even paying attention. Now it's too late. She has a major dislocation. This guy is hanging from a pendulum. He gets disoriented. He's spinning around. I don't know if he's supposed to handbrake, but handbraking is not a requirement in the standards. It's unfortunate. This accident is tragic too. So when does your zipline need an emergency brake or an EAD? The answer: when your zipline speeds exceed 6 miles per hour. The ACCT has defined that for over a decade. Ziplines with steep inclines should have an emergency arrest device or an emergency brake. Even ziplines operating indoors have EADs. I recommend you always have an emergency brake on your ziplines because over 50% of all accidents in the zipline industry are braking related. Let's look at some more resources about zipline braking systems. Headrush Technologies put out a white paper in 2017 that defined an EAD, or emergency arrest device. Pause to capture their link. Also, ANSI ACCT, or the Association for Challenge Course Technology, has published a standard that says in excess of 6 miles per hour, you need an emergency arrest device or an emergency brake. Let's move on. In the white paper from Headrush, they dive into various aspects of emergency brakes or emergency arrest devices. In the paper, you'll find out that spring packs are the most lucrative and safe zipline braking system on the market. Now granted, sometimes you'll have to have a longer platform, but these spring systems have safely stopped zipliners at Park City Mountain Resort in Park City, Utah for over 22 years. Next question. How can we capture arrival speeds with a speed gun? Well, the answers include: aim the gun parallel or in line with the arriving test weight. And we recommend you use test weights, not zipliners, to test your speeds. Speed guns should be calibrated every year for accuracy. Some speed guns can capture speed with just a clear line of sight, so they can be perpendicular to the zipliner. Capture your arrival speeds with the maximum weight, because weight does make a difference. And temperature is also a factor. Let's look at this Bushnell speed gun video. Notice how the ball is parallel with the gun. You're reading a 64 mile an hour pitch. Please note that some guns can, with different lines of sight, say over there by the maroon car on the right, could capture the speed correctly. but they usually cost $400 or $500. This gun's only about $150. Question number 4. Can a runner's GPS watch capture arrival speeds? Well, the answers are yes. A running or biking GPS watch can capture arrival speed data with GPS tracking. And yes, GPS watches are a convenient and portable option. And yes, some watches capture speed, temperature, and elevation. And yes, staff inspectors should use them for real-time data. Next question. Can a Zipline owner estimate arrival speeds? Answers: yes. Zipline owners can estimate arrival speeds with simple algebra. The speed equation distance over time also works, but different weights and outside temperatures will vary the speeds. And yes, even if there is only 10 foot of height difference between platforms, you can estimate arrival speeds. And yes, anyone can capture arrival speeds with a little bit of math. Let's take a look at this simple physics video so you can understand the knowns and what you're looking for, the unknown, which is the speed. What you'll be watching here is a simple free fall demonstration to find out what the V final is, or the final speed, in a free fall equation, very similar to the impact velocity equation. So let's watch this right now.
In this video, I'm going to cover another free fall type problem. So our problem for today is a ball is dropped from a 20-meter building. How fast is the ball traveling just before it hits the ground? So as always, we should start with our known and our unknowns. We start off in the problem, it tells us that the ball is dropped. So that in itself is a known value. When things are being dropped, that tells us that the initial velocity is 0 meters per second. It's dropped from a 20-meter building, so that's going to give us our height, which is our delta y. And since it's falling downwards, we're going to attach a negative value to it. As the ball falls, it falls in free fall. We know that the acceleration in free fall is that of gravity, so negative 9.8 meters per second squared. And then our unknown value here, since it's asking how fast just before it hits the ground, we are trying to find VF.
And VF is exactly what we're looking for between platforms with the impact velocity formula that we'll learn in the mathematics section. And we're finished. Thanks for watching. I hope you learned how to determine zipline arrival speeds. Thank you again.